Hello, this is Mrs. Lehman, and today our topic will be dividing fractions. So I'm going to combine a few of these lessons together just so that you can get the info you need for lesson 7, 8, and I'm not sure if it's 9, I'll have to look. But either way, this lesson focuses on dividing fractions by whole numbers, by mixed numbers, and by fractions. So one thing that is kind of a new thing in the past handful of years is using a model to divide fractions. So I'm just going to show you how that looks in case you ever come across one. If you find it easier, then feel free to use this method. Personally, I myself find the algorithm to be the most efficient and reliable, just because there are a lot of steps to remember even in drawing the diagram. So I don't feel like it's necessarily any easier. It may help you visualize what's happening though, so there is benefit to that. So division models, if you have the number 1 and you divided it by 4, what we would do is say, okay, the whole number here, whoops, I wanted that to be a highlighter, let me try that again. So this whole section is 1, right, and we're dividing that by 4. So I'm going to draw some horizontal lines to make that into 4 sections. Then what you do is you circle the top highlighted row. So in this case, we have 1 box out of a total of 4. All right. So we would say 1 divided by 4 is 1/4. And you guys know 1 over 4, that division or that fraction bar is representative of division too. So that makes sense, hopefully. We will use the same model with dividing fractions. So if we have 1/2, first of all, we want to represent 1/2. So if we take 1, we're going to split it into 2 sections, right? And I'm going to color that in. So what I have highlighted in yellow represents 1/2. I want to divide this by 4 though. So I'm going to draw some horizontal lines to make 4 cuts across there. And what we're going to do is circle the top highlighted row. So again, we have 1 section out of a total, and you're going to count highlighted and unhighlighted sections here. 1 out of 8 sections, so 1/8. All right, and then this next example, if we had 1/5 divided by 2, we're going to draw 1/5 and highlight that in yellow in this case. You could just lightly shade it with a pencil, obviously, and then we're going to divide that by 2 like this. So again, as I had done in the previous 2 examples, you're just going to circle the top highlighted section. There is 1 there out of a total of 10 boxes. So we have 1/10. All right, we're going to move on to this next example, and you'll see what happens when we have more than just 1 section highlighted. So we have 3/4 here, so there's a half and there are 4ths. Now I'm going to highlight 3 out of the 4 because the number we're chopping up is 3/4, right? And we're chopping it into 4 pieces. So I'm going to draw 1, 2, 3 horizontal lines. I'm going to circle the top section that is highlighted, so that represents 3 boxes out of a total of, and when you count up all the boxes, you have 16, so 3/16 is our answer there. So if you're wondering how to do the model of any of these, that's how you do it. You represent the first fraction, then you divide it into the divisor's number of sections. That sounds really confusing. So like with 1/2 divided by 4, you're going to represent 1/2, and then split it into 4 sections, and then circle the top highlighted one. That's your numerator, so in that case 1. And then how many total sections you have, highlighted or not, is going to be your denominator. All right, so I know that was kind of a quick explanation, but I'm going to move on to page 31 with you. And when we talk about the algorithm for dividing fractions, it involves multiplying fractions, and it involves the reciprocal. So you need to know what a reciprocal is. So a reciprocal is the multiplicative inverse of a number or fraction. And basically what that means is you're going to flip that fraction on its head, all right? You're going to flip it right upside down. And some teachers like to get kids to remember this by calling it the reciprocal, which, you know, whatever. That's a way to remember it too. So 2/5, the reciprocal of that is 5/2. It's just flipped upside down. In no way is 2/5 equal to 5/2. It's just when you multiply a number and its reciprocal, and this is key information, so you should highlight this. If you, I'm going to put stars by it. If you multiply a number by its reciprocal, you will get 1 every time, without fail. All right, so they give the example 1/3 times its reciprocal, 3/1. When you multiply, you could cancel out the 3 with the 3 and the 1 with the 1. And even if you didn't, you'd get 3/3, right? Which equals 1. So if we did that with the example up here, 2/5 times 5/2, you're going to get 10/10, right? Multiplying straight across, that equals 1. So this even works with whole numbers. So if we have the number 5, the reciprocal of 5 is 1/5. So if we took 5 and we multiplied it, so 5/1 times 1/5, or 1/5, you're going to get 5/5, which is the same as 1. Let's do maybe 6/7. All right, so multiply it by its reciprocal, 7/6. We could simplify this, but even if you didn't, you'd get 42/42, which is 1, right? If we simplified it, we'd get 1/1, which is 1. So one skill you need to have is finding the reciprocal. So your first step is, if it isn't, or if the number doesn't have just a numerator and denominator, you've got to get it so that it is a fraction, numerator and denominator. Okay, you don't want any mixed numbers, you don't want any whole numbers. So you've got to get the fraction in that form first, then find the reciprocal. All right, so we have 7/10. That would be 10/7 as its reciprocal. All right, 1/2's reciprocal, again, not equal to it, but the reciprocal is 2/1. Now 8, another way of saying 8 is 8/1, right? So that is not the reciprocal. We've got to still flip it upside down. So we would get 1/8 as the reciprocal. 2/3 reciprocal would be 3/2. And then 2, whoops, let me go back. I like to scroll through the pages by accident. It's my new hobby. All right, so we would write that as 2/1, right? So the reciprocal of 2/1 would be 1/2, or 1/2. 1 can be written as 1/1. If we were to flip 1/1, we would still get 1/1. Okay, so just to reiterate, I'm going to write this down at the bottom. A number and its reciprocal are not, capital letters for emphasis, equivalent. They are not equivalent. So a lot of kids think that. No, they're not. A $0.50 is not worth the same as $2, right? So you put things in terms of money, people tend to understand. All right, so 32, page 32 is a nice, beautiful blank page that we can use to take some notes. So this is where I'm going to teach you the algorithm, or the standard step-by-step process of dividing fractions. So at the top of that page, I'd recommend that you write to divide fractions. All right, step number 1. Rewrite the problem so that all mixed numbers or whole numbers have a numerator and denominator. or another way we could say this is put all numbers in fraction form. So we are not doing anything with the division yet, or not doing anything with the reciprocal yet. The first step is to just simply make sure every number has a numerator and denominator. So you're going to convert any mixed numbers to fraction, an improper fraction. You're going to convert any whole numbers to an improper fraction. All right, so that's step one. Step two is the fun part, okay? This is where we can use a variety of different mnemonic devices or memory tricks to remember the steps. So back in the day, way back when, nobody taught me any fancy, fun, exciting sayings for this. We were just told to multiply the first number by the reciprocal. So we just were simply told multiply by the reciprocal. All right. Now, the kids these days, they get to learn this fun stuff where they can say copy dot flip. So this means you write down, you copy the first number down, and then you change your multiplication or your division to multiplication. So take your division sign and turn it into a dot. And then flip means we're just going to find the reciprocal of the second number. So we'll do a few practices, but if you can remember copy dot flip, some people like to say it this way. So you keep the first number, change your division to multiplication, and then flip your second number. Now you can't, and you guys know this, you can't just go switching between multiplication and division for the heck of it, right? You need to make it math legal, all right? You need to make sure you haven't changed the values of things, right? So in order to do that, if we're changing division, that's fine. We're going to change division to multiplication, but because we switched that to its inverse, we also have to change that second number to its multiplicative inverse as well, all right? So we'll practice. But anyway, multiply by the reciprocal, copy dot flip, keep change flip. Some people shorten that to KCF, which whatever. I don't really love that because all I can think of is chicken. Kentucky Fried Chicken, and then I have it out of order, so whatever. And then one that my class came up with a few years ago, and I thought it was pretty fun. I think maybe a kid had come from a different school district and said, my teacher said drop switch flip, and I said that's cool. And then all we could picture, at least this is what was going on in my head, which sometimes I'm sure you think is a scary place, but I promise it's not bad. Drop, switch, flip makes me think of like a dubstep thing or something, like, I don't know, pardon the terrible musical abilities here, but can't you picture in the math world, like drop, switch, flip, and then like the beat drops? I don't know. Anyway, then you're going to, once you did that stuff, you're going to just multiply or simplify first or simplify at the end. And then your next step is to make your answer pretty. So, how do I want to say that? You want to put, change any improper fractions to mixed numbers. And then, and then label if needed, obviously. All right, so the first step, again, is you're going to rewrite the problem so that you have everything in fraction form. Second step, you're going to change your multiplication to division. I said that backwards another time. Oh my gosh, you're going to change your division to multiplication. Let me say that correctly. you're going to change your division symbol to multiplication, and then what you're going to do is flip that second number to its reciprocal. So you've changed division to multiplication, and you've changed that second number to its multiplicative inverse, okay? And you can use any of the sayings, copy, dot, flip, keep, change, flip, which I like copy, dot, flip, if I'm being honest, and drop, switch, flip. Then you're just going to multiply straight across or simplify, and then you're going to make your answer pretty at the end. All right, so let's practice a few together. Personally, I think we should be doing the reciprocal questions first. All right, so if we have, that's not 9.5, that's question number 9, question number 10, 11, 12, 13, and 14 that you see there. So anyway, the reciprocal of 1 over 2, or 1/2, is 2 over 1, or 2, right? So make sure you're not writing 1/2 equals 2 over 1, because again, 1/2 does not equal 2. The next one, 2/7, if we were to flip that upside down, we'd get 7 over 2, right? The next one, we have 7, or how we would rewrite 7 is 7 over 1, right? So the reciprocal of 7 over 1 is 1/7. 8/5, the reciprocal of that would be 5 over 8. And then 34, again, 34 we could express as a fraction first, 34 over 1, and then to find the reciprocal, we're gonna switch that around to 1 over 34. And then in this example, number 14, we have 2 1/5, right? So just to review, we're gonna multiply, let me zoom in. We're gonna multiply the 2 and the 5, that's gonna give us 10. We're gonna add the 1. So 2 1/5 is the same as saying 11/5. Right, so the reciprocal of 11/5 would be 5 over 11. Alrighty, so now that we have that skill down, we're going to practice a few of these. So your first step, just to review, we're going to rewrite the problem so that all mixed numbers or whole numbers have a numerator and denominator. So 2/4 would stay the same, that's all set for us. Divided by, notice I'm not getting into switching anything yet as far as our operation, keep it division. And then 3, instead of writing 3, I'm going to write 3 over 1. Okay, so step 1 is done. The next step is going to be to copy, dot, flip. So I'm going to copy that first number, 2/4, dot. This is where I change my division to multiplication, and then flip that second number, 1 over 3. And when you multiply, you may want to simplify first. Again, kind of personal preference here. I'm going to simplify before I multiply. 2/4 is the same as saying 1/2, right? So now I'm going to multiply 1 times 1 is 1, and then 2 times 3 is 6. So if we were to take 2/4 and we split it into 3, we would have 1/6. Okay? The next example, similar to the first one, we're going to have 1/5 divided by, and instead of 8, we're just going to throw that 8 over 1. That's the same math problem. Now what we're going to do is copy, dot, flip. Keep, change, flip. So keep the first number the same, change your division to multiplication, and then flip this to 1/8. So we change that division, therefore we need to change that second number to its reciprocal. So we're going to multiply straight across the top. 1 times 1 is 1, and 5 times 8 is 40. So we have 1/40. In the next example, we have 1/6 divided by 6, and I don't need to do every one of these with you, but I do want to do a few. So 1/6 divided by 6 over 1. So first step, get it in fraction form. Now, we've done copy, dot, flip, keep, change, flip. Let's do drop, switch, flip. So drop, switch, flip is with the assumption you're writing it beneath the first problem. So we're going to drop that first one. We're going to flip that second one. Switch it, whatever we said. All right, so 1 times 1 is 1. 6 times 6 is 36. All right. Pretty easy stuff. So let me scroll ahead And the same rules apply when we're taking a fraction and dividing it by a fraction. So I've skipped ahead to page 36, and I'll do a few examples with you on page 36. So at the top, just as a reminder, I'm going to write keep, change, flip, or you can write my favorite, which is copy, dot, flip. And if you want to be super old school, nothing fancy, multiply by the reciprocal. All right, so we have 1/4. We're going to keep the same, or the first number the same. Then we're going to change our change our division to multiplication. So make it a dot, and we know the dot represents multiplication. Then we're going to flip that second number, so 10/9. And you can simplify before or after, and you know my thoughts on that. Doing it ahead of time is a little easier. So I'm noticing that 4 and 10 are both even, so I'm going to divide them both by 2. So 4 divided by 2 is 2, 10 divided by 2 is 5. So when I multiply across, I get 5/18. All right. I'm going to do every other one with you just because time is a thing. All right, so both of these numbers already have a numerator and a denominator, so we're ready to roll there. So 1/3, I'm going to copy, dot, and then flip. So instead of 6/9, I'm going to write 9/6. And there's some simplifying to be done here. 9/6 could be simplified, right? Those numbers are both divisible by 3. If I take 9 and divide it by, let me zoom in, 9 and divide it by 3, I'm going to get 3. And if I take 6 and divide it by 3, I'm going to get 2. And then if you look diagonally now, we have a 3 and a 3, right? So 3 divided by 3 is 1, 3 divided by 3 is 1. So when you multiply straight across, you're going to get 1/2, or 1/2. All right, the next one I'm going to do with you is question number 5, 8 divided by 1/4. So first step, if you scroll back a few pages, and I will do that because I know, what would you do? You're going to rewrite the problem so that all the mixed numbers or whole numbers have a numerator and denominator. So going back here, question number 5, I need to rewrite this. So 8, I need to have a denominator. So 8/1 divided by 1/4. A lot of kids get really anxious to start writing, flipping, and doing all this stuff. If you skip these steps, I'm telling you what, you're gonna skip a step and fall, because you just goof up that way. Trust me, I've seen it. All right, so let's drop, switch, flip it. So I'm going to drop that first number. Ooh, let me write that a little bit bigger. I'm zoomed way in, so it looks very digity. I'll zoom out a little bit. What would you do without the play-by-play, you know? All right, so 8/1. We're going to drop. We're going to switch our division to multiplication. Drop, switch, flip. All right, so 4/1. When you look to simplify, you're going to see there's nothing to simplify, right? So 8 times 4, we're going to get 32/1. And when you have 32/1, that's the same as saying 32. So our answer there is 32. The next set of examples that they give us are a bunch of word problems, and we have mixed numbers here. So we can do a word problem example soon. But in the meantime, let's just do a few more with mixed numbers, okay? The same rules apply. If you go back to this page, same rules apply. Rewrite the problem so that you have the numbers in fraction form, numerator and denominator, no whole numbers, all right? And then you're gonna drop, switch, flip, keep, change, flip, copy, dot, flip. You're going to do your multiplication, any simplifying you need to do, and then obviously if you need to label, we always look to do that. So I am now probably giving you a headache. We're going to be on lesson 9, page 39. All right, so the first review question here at the top, it says, what is the reciprocal of 2.5? So first of all, we need to figure out what is 2.5 as an improper fraction. So 2.5, we're going to multiply the 2 and the 2, we're going to add 1. So we're going to have 5 halves, right? So the reciprocal of that would be 2 over 5. All right, so you need to remember that there's more than just the step of changing it into an improper fraction. To find the reciprocal, you still have to do the flipping. So here we go. Okay, so let's look at example 1 here. 4/5 divided by 2 1/3. So our first step is to rewrite the problem so that there are only fractions that have a numerator and denominator. So 2 times 3 is 6, plus 1 is 7. And we're going to keep the same denominator as we had before, which is 3. All right, and now what we're going to do is keep, change, flip. Copy, dot, flip. So copy the first one down. We're going to change our division to multiplication, and then we're going to flip this to 3/7. All right. Now we're just going to see if we can simplify anything. These fractions are both in lowest terms. You're going to look diagonally. Is there anything we can simplify before we multiply that way? And there isn't. So what we're going to do is just multiply straight across. We're going to get 12 over 35. Okay, so that is how you do that. Let me do another example with you. Let's do, I like the looks of question 4. All right, question 4. So we're going to get these to be improper fractions first. All right, so we're going to multiply here. That's going to give you 24. Add your 3. 24 plus 3 is 27. And then we're going to keep it over 4. Then right here, we're going to multiply 2 times 5, which is 10. Add 2. We're going to get 12 over 5, right? So we're going to now keep, change, flip. So keep the first number the same. Change this to multiplication. Then flip this number to its reciprocal. All right, now I'm looking for anything that can be simplified, and 27 and 4 do not share any common factors, and 5 and 12 do not share any common factors greater than 1 either. So I'm looking diagonally. 12 and 27 aren't really compatible, and 4 and 5 don't share factors. So we just need to multiply at this point. So 27 times 5 is what I'm doing. 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. So we're going to have 135 over 4 times 12. You could do the multiplication on that, but hopefully you know this one is 48. All right. So again, our last step, as we said way back here, is to change any improper fractions to mixed numbers and label if needed. So where'd it go? Where'd it go? All right, so we have to change 135 over 48 into a mixed number. So to do that, I'm going to say 135 divided by 48. So I know 48 is pretty close to 50, so if I did that by 3, it'd probably be too high because we'd be looking at a number pretty close to 150, so I'm just going to double it and see what we get. So 2 times 48, when you do that, you're going to get 96, right? So let's try that. 2, write your 96 here, you're going to subtract. You need to do some borrowing. 15 minus 6 is 9. 12 minus 9 is 3. So, let's see, I'm just paranoid I miscalculated on that. Let me just double check my work. Borrowed, carried, okay, so 15 minus 6 is 9, 12 minus 93. All right, I'm good. So what do I do with this number? Well, you put it up here as the numerator, 39, and then you take this number right here as your denominator, 39 over 48. So the answer is 2 and 39. That was not wanting to write for me. 39 over 48. So that's how it's done, kids. And it's too bad you couldn't zoom in on paper. We'll focus on word problems in another example or in another video, and I can go through more examples with you, but hopefully this gave you a thorough understanding of the process of dividing fractions. So just keep in mind the order, the algorithm to do this. Rewrite the problem so mixed numbers and whole numbers have a numerator and denominator. Do not touch the division sign yet. In the next step, you're going to copy dot flip, and then you can go ahead with your multiplying and simplifying process and then cleaning up your answer.